advent of fifth-generation fighters has revolutionized modern warfare, serving as a hallmark of a nation's military prowess. These aircrafts aren't only a symbol of power, but also a game-changer on the battlefield. Recently, Ukraine achieved a significant milestone by downing a Russian Su-57, Moscow's prized fifth-generation fighter. This development raises questions about this aircraft's capabilities and effectiveness. Can the Su-57 really compete with the F-35? Join us as the new F-35, the only U.S. fighter jet to best Su-57, shocked the Russians. Russia's supposed fifth-generation fighter. While the United States and its NATO allies have the fifth-generation all-weather stealth multi-role combat, Lockheed Martin F-35, the Russian equivalent is the Sukhoi Su-57, NATO reporting name Felon. In 1957, long before the fall of the Soviet Union, the Kremlin had identified the need for a fifth-generation fighter jet with stealth capabilities that could be used in multiple, including ground attacks. Mikoyan and Sukhoi began designing two different aircraft in 1983 to meet the requirements. Following the fall of the Berlin Wall in November 1989, Soviet Union leader Mikhail Gorbachev tried to introduce a series of reforms known as perestroika to end a decade of stagnation. In August 1991, amid political turmoil, Russia, Ukraine, and Belarus declared the breakup of the Soviet Union. Severely hampered by a lack of funds, Russia canceled Mikoyan's project and concentrated on Sukhoi's approach of producing an aircraft that could replace the Su-27 and MiG-29. Sukhoi developed the aircraft based on the exciting Su-27, but added more advanced features to reduce development costs and spread the risks associated with creating a new aircraft. Originally called the T-50 before changing the name, the aircraft suffered from numerous delays and made its maiden flight on January 29, 2010. 10 prototype aircraft were built for testing purposes, but structural cracks were discovered on the airframes. This further set the project back and led to a redesign incorporating more composite material and a slightly longer wingspan. Further issues and accidents during testing led to the SU-57 introduction being pushed back from 2015 to 2020. Another problem the aircraft faced was that it cost much more than the Su-35S and Su-30M, causing the Russian government to delay production. Things changed drastically for the better in 2019 when Russian President Vladimir Putin announced that he wanted to purchase 76 Su-57s and have them delivered to the Russian Air Force by 2018. Production of the Su-57 followed, with the first plane being delivered to the Russian Air Force in late 2019. Following Russia's invasion of Ukraine in February 2022, international sanctions imposed by the West and Russia's inability to trade using US dollars have hampered production. Russia cannot procure the semiconductors and high-end machines needed to build the Su-57 from the European Union. While there is no public record of the exact number of Su-57s active in the Russian Air Force, it's somewhat clear that Russia is hesitant to use the plane in combat. They are apparently worried about some of its secretive, sensitive technology falling into the hands of the West, and also what it would do to future export sales if one were to be shot down. According to the Eurasia Times, citing Russian media, Russia used a Su-57 in May 2022 to fire missiles at targets in Ukraine from Russian airspace out of range of Ukrainian surface-to-air missiles. While being interviewed, Russian Defense Minister Sergei Shoigu described the Su-57 as having performed brilliantly, but provided no documentation to back it up. So, what are the features of this Russian's prized assets compared to its predecessors? And how do they compare to other fifth-generation fighters? Features of the Su-57. Russia's first operational stealth aircraft is a multi-role fighter that prioritizes super maneuverability, versatility, and advanced sensors. Designed to overcome the limitations of the F-22, this fighter boasts a unique blend of stealth, thrust vectoring, and advanced materials. Its wide fuselage, trapezoid wings, and all-moving stabilizers enable extreme maneuverability, while its internal payload bays and advanced sensors make it a formidable multi-role fighter. With a top speed of Mach 2 and the ability to supercruise at Mach 1.3, the SU-57 definitely outperforms previous generations of aircraft. Its high fuel load and extendable refueling probe give it a supersonic range of over 1,500 kilometers, making it a valuable asset for the Russian armed forces. The advanced flight control system, thrust vectoring nozzles, and relaxed stability enable it to perform high-angle maneuvers like the Pugachev's Cobra and Bell maneuver, making it a highly departure-resistant and maneuverable aircraft in all axes. Russia's cutting-edge fighter jet is powered by two NPO Lyulka Saturn Izdelie 117 augmented turbofans, each producing an impressive 9 tons of dry thrust and 14.5 tons in afterburner. These engines boast full authority digital engine control and are integrated into the flight control system, enabling exceptional maneuverability and handling. The AL-41F1 engines feature thrust vector control with canted nozzles, allowing for thrust vectoring moments around all 3 aircraft axes. However, concerns have been raised about the engine's reliability and performance, with the Indian Air Force expressing concerns in 2014. Additionally, a compressor stall incident occurred during the 2011 Moscow Air Show. To address these issues, a new engine, the Izdelie 30, is being developed for the Su-57M, with an estimated thrust of 11 tons dry and 17 tons in afterburner. This new power plant promises improved performance, reliability, and reduced radar and infrared signatures. In a further development, UEC Saturn is planning a 6th-generation engine design for the Su-50, showcasing Russia's commitment to advancing its military technology. As of December 2023, all Su-57 fighters delivered to the Russian Air Force are reported to be powered by the advanced Stage 2 engine, also known as Izdelie 30. This fighter also boasts an advanced weapon system, with 2 tandem main internal weapon bays and 2 side weapon bays, allowing it to carry a wide range of ordnance. The main bays are equipped with ejection launchers, capable of carrying missiles weighing up to 700 kilograms, while the side bays use launch rails. For air-to-air combat, the Su-57 typically carries 4 beyond visual range missiles and 2 short-range missiles. The primary medium-range missile is the R-77M, an upgraded variant with advanced seeker and motor technology. The short-range missile is the R-74M2, an infrared homing missile with reduced cross-section for internal carriage. A new short-range missile, the KMD, is currently under development. For longer-range applications, the Su-57 can carry the Izdelie 810 missile, a development of the R-37M with updated motor and seeker. The aircraft can also carry precision-guided bombs, air-to-ground missiles, anti-ship missiles, anti-radiation missiles, and cruise missiles. Additionally, the Su-57 has 6 external hardpoints for carrying stores, allowing it to utilize most Russian tactical fighter weapons. A new hypersonic missile, similar to the KH-47M2 Kinjal ALBM, is being developed with intra-body accommodation and smaller dimensions to allow internal carriage. The aircraft is also equipped with a 30mm autocannon with 150 cartridges, effective against both aerial and surface targets. With its advanced weapon system, the Su-57 is a formidable opponent in the skies. Is that all it is to Russia's bodyguards? A marvel of stealth technology. The fighter jet is a marvel of stealth technology, employing a range of innovative features to minimize its radar signature. By aligning planform edges, angling surfaces, and utilizing radar-absorbent materials, the aircraft significantly reduces its radar cross-section. Weapons are stored internally in weapons bays within the airframe, and antennas are recessed to preserve the stealthy shape. Even the engine face is masked with a blocker grid and ram coatings to reduce reflection, making it difficult for radar waves to detect the aircraft. The aircraft's canopy is coated with 70-90 nanometers thick metal oxide layers, which not only absorbs radar waves, but also protects the pilot from the impact of ultraviolet and thermal radiation. The production tolerances are significantly tighter than previous Russian fighters, resulting in a 30-fold reduction in radar cross-section compared to the Su-27. The Su-57's design prioritizes frontal stealth, with RCS reducing features most apparent in the forward hemisphere, making it ideal for penetrating enemy airspace undetected. While its low observability measures are effective against super-high-frequency radars, the aircraft may still be detectable by low-frequency radars due to its size. The Su-57's stealth capabilities make it a formidable opponent in the skies, allowing it to evade detection and engage targets with precision. The combined effect of airframe shape and ram of the production aircraft is estimated to have reduced the aircraft's RCS to a value 30 times smaller than that of the Su-27, making it one of the stealthiest aircraft in the world. Sukhoi's patent for the T-50 stealth features cites an intention to reduce average RCS to approximately 0.1 to 1 meter square, compared to its predecessor's RCS of approximately 10 to 15 meters square, demonstrating the significant advancements made in stealth technology. The Su-57's design is a testament to Russian engineering and stealth technology, making it a valuable asset for the Russian military and a formidable opponent for any adversary. This fighter also features a cutting-edge glass cockpit, devoid of analog gauges, where information is displayed on two 15-inch main multifunctional LCD displays, similar to the Su-35S. It apparently didn't totally leave everything behind. A smaller multifunctional display and digital control panel supplement the primary display. The cockpit also boasts a wide-angle head-up display, and primary controls consist of a joystick and throttles, with all major functions controlled via hands on throttle and stick. The aircraft's canopy is a two-piece design, with the aft section sliding forward and locking into place. The Su-57's integrated computer system utilizes the chip 1890VM8Y FGU FSC NISI, while the NPP Zvezda K-36D5 ejection seat and SOG-50 life support system ensure pilot safety. The life support system includes an anti-G and oxygen generating system, providing unlimited oxygen supply and enabling 9G maneuvers for up to 30 seconds. The pilot wears a ZSH-10B helmet with the NSTS I-50 digital display system, enhancing situational awareness and allowing engagement of targets at high angles off bore sight. The ejection seat and PPK-7 flight suit enable safe ejection at altitudes from 0 to 20,000 meters and instrument airspeeds from 0 to 1,300 kilometers per hour. A survival kit is also included to assist the pilot after ejection. The PAKFA program's primary technical objective is to achieve seamless integration of avionics systems, fostering enhanced sensor fusion, elevated pilot situational awareness, and reduced workload. The Su-57's onboard systems integration is masterfully controlled by the Information Management System, with its computer system developed by GRPZ from Ryazan. The aircraft's main avionics systems include the SU-57 multifunctional integrated radio-electronic system and the 101KS Atoll electro-optical system. Notably, Sukhoi took the lead in integrating the IUS systems, a departure from previous collaborations with RPKB of Ramenskoye. The resultant integrated avionics suite, dubbed Integrated Modular Avionics Combat Systems, leverages fiber optic channels and operates on an impressive 4 million lines of code, ensuring a harmonized and cutting-edge avionics system. The avionics system makes it a formidable opponent in the skies. At the heart of its technological prowess lies the Shi-121 avionics suite, a masterful integration of radar, electronic countermeasures, and communication systems. The suite comprises the N036 Bielka radar system and L402 Himalayas electronic countermeasures system, both developed by Tikhomirov NIIP Institute. The radar system is a marvel of modern technology, featuring a main nose-mounted X-band AESA radar with 1,514 TR modules, as well as two side-looking X-band AESA radars with 404 TR modules embedded in the forward fuselage. This configuration provides unparalleled angular coverage and enables the SU-57 to employ advanced tactics such as beaming. In addition to its radar capabilities, the suite also features two top-notch band transceivers on the wing's leading-edge flaps, which handle friend or foe identification and electronic warfare tasks. The suite's processing units work in tandem to enhance the X and L band signals, providing the pilot with a comprehensive view of the battlefield. There is another key component of this avionics suite that utilizes both its own arrays and the N036 radar system to provide robust electronic countermeasures capabilities. Developed by the Kaluga Research Radio Engineering Institute, the suite is designed to detect and neutralize enemy radar and electronic threats. Finally, the S111 system, developed by Polyot, enables redundant radio-telephone communication and encrypted data exchange among various aircraft and command centers, ensuring secure and reliable communication in the heat of battle. The SU-57 also boasts an impressive array of sensing and navigation capabilities. The heart of its technological prowess lies in the ATOL electro-optical system, a comprehensive suite of sensors that enhance the aircraft's situational awareness and combat capabilities. The ATOL system consists of multiple components, including the 101 KSV infrared search and track system, the directional infrared countermeasure system, the ultraviolet missile approach warning sensors, the thermal imager for low-altitude flight and landing, and the navigation and targeting pod. The IRST turret, mounted on the starboard side, can track multiple targets simultaneously, while the DIRCM system, a first for any fighter aircraft, provides additional protection against infrared threats. In addition to its advanced sensing capabilities, the SU-57 also features a range of countermeasures, including flares, radar decoys, and single-use programmable ECM transmitters. These countermeasures are deployed through dispensers mounted in the tail boom between the engines, providing an added layer of protection for the aircraft. For navigation, the Su-57 relies on an inertial navigation system, developed by Concern Radio Electronic Technologies. This system integrates with Russia's GLONASS satellite navigation system and is controlled by the IVS-50 computing system, providing the aircraft with accurate and reliable navigation capabilities, which has since undergone further development in 2016. Furthermore, Russia's prized asset features a monitoring system that uses optical fibers to assess the aircraft's condition and predict the remaining lifespan of its composite parts. This system streamlines maintenance and repair processes, ensuring that the aircraft remains in top condition at all times. In a significant milestone, this aircraft has also tested autonomous flight without pilot input, demonstrating its potential as a test bed for advanced AI and unmanned teaming technologies intended for use in future sixth-generation fighters. Seeing as the Su-57 was supposed to be the Kremlin's answer to other true fifth-generation fighters and the multinational F-35, but Russia's stealthy superfighter never really got off the ground. After reports came out that Ukraine had turned one of these Russian supposedly fifth-generation fighters into debris, people are beginning to wonder if the Su-57 is truly as ultra-modern as the Russians have claimed. So, what's wrong with the Su-57, and how does it compare to modern fighters like the F-35? The focus on stealth and network-centric warfare. Russia embarked on the development of its next-generation fighter jet, the Su-57, a project that would span decades and has faced numerous challenges. As Russia's first stealth fighter, the Su-57 was designed to be a game-changer, but its production has been significantly limited due to economic sanctions and the ongoing conflict with Ukraine. In contrast, the American F-35 Lightning II has been widely produced and has established itself as a benchmark for fifth-generation stealth fighters, boasting superior stealth and sensor capabilities. Although the SU-57 excels in speed and offensive power, reaching incredible speeds of Mach 2, outpacing the F-35's top speed of Mach 1.6. However, the SU-57's design prioritizes agility and speed over stealth, which may compromise its radar cross-section and infrared signatures. Unlike the F-35, the SU-57 has external weapons pylons and engine nozzles, which can increase its radar signal, making it more detectable. Additionally, its canards and design materials may not be optimized for stealth, further limiting its ability to evade detection. While the SU-57 incorporates some stealth features, its radar cross-section values are significantly higher than those of the F-35. The F-35's radar cross-section is estimated to be around 0.0015 square meters, a remarkably small signature that makes it difficult to detect. In contrast, the SU-57's radar cross-section ranges from 0.1 to 0.5 square meters, a significantly larger signature that may make it more vulnerable to detection. The SU-57's unique design sets it apart from other fifth-generation stealth fighters, but its stealth capabilities may be limited by its structure and design choices. The aircraft's emphasis on speed and agility has resulted in a larger and more detectable radar signature, which may compromise its ability to conduct stealth missions. In contrast, the F-35's focus on stealth and network-centric warfare gives it a significant advantage, allowing it to conduct missions with a high degree of stealth and coordination. In summary, both aircraft have distinct strengths, but the F-35's focus on stealth and network-centric warfare gives it an advantage in the skies. The SU-57's speed and offensive power make it a formidable opponent, but its stealth features are definitely not on par with those of the F-35. As the world of military aviation continues to evolve, it will be interesting to see how these aircraft are developed and improved upon in the future. Engines of the future. The SU-57 and F-35 are two of the most advanced fighter jets in the world, boasting cutting-edge technology and impressive performance capabilities. At the heart of these aircraft are their powerful engines, which play a crucial role in determining their speed, range, and overall effectiveness. The F-35, powered by the Pratt & Whitney F-135 PW100 engine, is a force to be reckoned with. This turbofan engine produces an impressive 28,000 pounds of thrust in dry conditions and up to 43,000 pounds with reheat. With a top speed of 1,199 miles per hour and a range of 1,379 miles, the F-35 is a formidable opponent in the skies. In contrast, the SU-57 boasts two Saturn AL-41 F1 engines, each producing 35,000 pounds of thrust. This twin-engine configuration allows the SU-57 to achieve incredible speeds of up to 1,616 miles per hour and cover vast distances of 3,107 miles. The SU-57's engines are designed to provide superior power and maneuverability, making it an excellent choice for air-to-air combat and ground attack missions. While both engines are impressive in their own right, the SU-57's twin-engine design gives it a significant advantage in terms of power and redundancy. In the event of an engine failure, the SU-57 can continue to fly safely on its remaining engine, whereas the F-35 would be forced to make an emergency landing. Additionally, the SU-57's engines are designed to be more fuel-efficient, allowing it to stay in the air for longer periods of time. A complex mission system. The avionics of the F-35 Lightning II are extraordinary. It's another aspect that separates which fighter is more elite in this discussion. For starters, the F-35 mission systems are considered among the most complex of any aircraft. The avionics and sensor fusion are designed to enhance the situational awareness of a pilot. Accordingly, it presents United States pilots with yet another tactical advantage in the sky. The F-35 is more than just a fighter jet, it's a force multiplier that enables command and control capabilities and network-centric warfare. This cutting-edge aircraft is equipped with a range of advanced sensors that make it a formidable opponent in the skies. At the heart of the F-35's sensor suite is the Northrop Grumman, an APG-81 AESA radar, a state-of-the-art system that provides unparalleled situational awareness. The BAE Systems, an ASQ-239 warfare system, adds another layer of capability, detecting and tracking threats with ease. The Northrop Grumman DAS system, or Distributed Aperture System, provides 360-degree coverage, giving pilots a complete view of their surroundings. The Lockheed Martin Electro-Optical Targeting System is another key component, offering precision targeting capabilities in a variety of environments. Rounding out the sensor suite is the Northrop Grumman Communications, Navigation, and Identification Suite, which enables seamless communication and navigation. Together, these sensors make the F-35 an unstoppable force in the skies, providing pilots with the information they need to make quick decisions and gain a strategic advantage. Whether in air-to-air combat or ground attack missions, the F-35's advanced sensors give it the edge it needs to succeed. The F-35 Lightning II is equipped with technology that presents a cohesive image of nearby battle space. Moreover, the stealth jet transitions into an electronic warfare system. Thus, the F-35 can detect and jam hostile radars as well as track approaching targets. Then, there is the SU-57 fighter to consider, which puts up a solid fight. Despite some delays, the SU-57 has sought to improve avionics to increase the pilot's situational awareness, like the F-35. Additionally, the avionics of the SU-57 are designed to reduce pilot workload. For this reason, the features could one day serve as a test pilot for advanced AI and man-unmanned operations in the sky. It's one of the many aspiring goals of future, sixth-generation fighters. For now, the SU-57 offers some impressive avionics of its own, including the ability to fly autonomously without pilot input. The onboard systems on the SU-57 are controlled by the Information Management System, the more tested weapon. The SU-57 and F-35 are both fully capable in terms of armament. The F-35 has more options for armament, including optional missiles, cannons, and bombs, though. In order to preserve the stealth profile, the design incorporates 2 internal weapons bays, each with 4 weapon stations. For this reason, there are many different options for what military personnel determine to load the bays with in terms of weapons. The 2 outboard weapon stations support heavier ordnance, while the inboard stations support air-to-air missiles. Moreover, air-to-surface weapons are mounted on the outboard station, including the Joint Direct Attack Munition and Joint Standoff Weapon. The station also supports multiple smaller munitions, GBU-39 bombs, Spear-3 anti-tank missiles, and so on. The AIM-120 AMRAAM is mounted on the inboard station. Furthermore, the F-35 profile utilizes 6 external weapon stations for missions that do not require stealth. The standard armament for the F-35A is a 1 multiplied by 25mm GAU-12U internal 4-barreled automatic cannon. Finally, the wings maintain their own armament stations. The Su-57 does not support nearly the same diverse collection of armament. Its weapons include a standard 1 multiplied by X-30mm GH-31 internal cannon and optional air-to-air or air-to-surface missiles. For air-to-air combat, the Su-57 features 4 beyond visual range missiles in the 2 main weapons bays. The armament is supported by 2 short-range missiles along the side bays. The primary medium-range missile is the active radar homing R-77M. Meanwhile, the short-range missile is the heat-seeking R-74M2. Furthermore, the SU-57 supports precision-guided bombs along with internal weapons. Lastly, with missions that do not require stealth, the Felon fighter provides 6 external hardpoints for weapons. But there is also the reputation of each aircraft to consider. The F-35 definitely offers more history and tradition. Its accomplishments in the air are much more impressive and noteworthy. For starters, the SU-57 has barely entered the sky, let alone achieved much in terms of operations. Furthermore, F-35 stealth fighters have been utilized by several other nations, including Israeli operations. The same is not true of the Felon, which lacks the same credibility. For starters, it's only been around a short period of time after arriving in 2020. Then, one must also consider its shaky beginning. The Su-57 has been dogged by development delays as well as disappointing trials. It has been announced that the first fully operational Su-57 regiment of 24 aircraft will arrive in 2025. On October 2022, it was confirmed that Su-57 fighters were involved in the invasion of Ukraine. For now, the Felon lacks the same reputation as the F-35 and other elite United States aircraft. The Sukhoi Su-57 Felon might have to wait a while before being able to compete with the F-35, because currently there is a very limited number of the Su-57 in service, and in the end, it may simply come down to numbers. Even more noteworthy, Russian pilots lack experience operating the Felon compared to United States experience with the F-35 variants. There is little debate. The Lightning II wins this battle. Yes, the Felon is bigger and faster, but that also makes it a larger target for the more stealthy Lightning II. In the end, it's hard to catch a fighter you cannot detect and first catch off guard. Sure, the Su-57 may feature some impressive capabilities, but that does little against the best stealth fighter on Earth. As a result, if you are predicting who would win in direct combat, it's hard to argue with the F-35 fighter. Thanks for watching. See you in our next video.